Perfect. All right, I'm recording as well. All right, thank you everybody for being here. We're going to start with the group activity number 2 for 119. And we are going to answer the questions from Clover Learning about collimation, starting with the first question. What term describes the process of restricting the size of the exposure field to the area being imaged? And the answer that I put was collimating is a term for restricting the exposure field because it describes adjusting the collimator blades to change the area size. That is what I put. Does anybody have something different?
No.
Nope,
I agree with you.
All right, perfect.
I agree.
Nice.
Word.
Okay, then we'll go on to the second question. And Sasha, you're going to answer this one.
Okay.
It says the collimated boundaries of the exposure field should always be equal in size to them.
I got the anatomy of interest because anything more than that is a necessary patient dose and it decreases the quality of the image because of the scatter.
Perfect.
Right.
Yeah, you actually
Yes.
had more than one I wrote. I didn't
Sorry.
include the image quality. That's really good. Anybody else has a different answer or maybe more details for the same question?
Yeah.
I agree. Yeah, I was a
agree.
little on that one. I was like, oh, well, is it supposed to be the size of the IR? But like you said, the anatomy of interest is much more, makes much more sense in this case because if we're doing a hand x-ray, we don't need the whole IR. So that was kind of how I come up with that.
That's a good way
Yeah,
to see
it's
it.
like the two
Definitely.
main points of this whole video. Yeah.
Mhm. Perfect. All right, then Kendra, you're going to answer the third one, and it says, which two of the following are advantages of using correct collimation?
Well, we did just answer this in the previous questions, but it was for
Sort of.
decreased patient dose
Mhm.
and not in Sarah's, but in Sasha's, and
Mhm.
then increased image quality because you want to reduce the scatter. And when you collimate, you decrease the patient dose because you're just limiting it to the anatomy within the collimation field.
Exactly.
It decreases the scatter.
And I think that's the key word, comparing it to the previous question, scatter radiation. I don't think we mentioned that, I'm not sure. But yes, I have something similar.
Okay.
And all right. And anybody else has anything for that question?
No,
No?
I totally agree. That was a good way of putting it, though.
Perfect. Okay, Viviana, question number 4. Collimator leaves must be constructed of highly attenuating materials such as?
I said lead. And because the other ones are, the density is much lower. So that's why I chose lead. But I don't
Perfect.
know exactly how to give another explanation of it.
It has a high atomic number,
Mhm.
so it's more attenuating. The electrons are more closely bound to the nucleus, so they can't be, the lead can't be ionized very easily at all.
Mhm.
So that's what I think what makes it radio opaque.
Yes, exactly. I think it goes along with the lecture that after a certain number on the periodic table, I think it depends on the number of shells an atom has. The more it has, the stronger the bond with the first shells. So in this case, the outer shell, the one that only fits 8 electrons. And so I think that's why lead is such a good one. Also, it's a very common metal, something like that.
Right, because it has so many protons
Mhm.
in the nucleus, it attracts the electrons more tightly.
Exactly. Perfect. Anybody else has any other comments for that one?
Yeah, I was a little torn because I was like, oh, well, what about aluminum? But then I was
Mhm.
thinking how aluminum's used in filtration because it's supposed to stop the less penetrating photons. So the thing with lead is it stops all the photons, right? So
Exactly. Yeah.
yeah, so that's kind of the difference there. And that's how I was able to determine if it was lead.
Yeah, you're right. Although I think the video does mention two materials, right, for the collimator, but was it aluminum, the other one, or was it
I believe it
tungsten?
was
Lead,
aluminum,
like
but
tungsten. It could be made of
Tungsten.
lead or tungsten.
Okay,
Aluminum does let through X-rays,
okay,
just
so
the higher quality ones.
yeah, so
Right.
the aluminum is good for the filtration. Okay,
Mhm.
makes sense. All right, we're going to go on to number 5, and Rocio, you're going to answer this one. What term describes the expansion of the X-ray beam as it travels through space?
I said divergent
Mhm.
because the beam, when it comes out of the window, it just travels like this. I didn't think any of the other answers were correct.
Perfect. Yeah,
Yeah.
that pretty much sums it up. Does anybody have any other answer for that one? Or another explanation of it? No?
Got my contact lens, excuse me.
No, you're okay.
Sorry, I just got
Um,
it.
I did include that it's just like the light on a flashlight. That's the only different thing that I
Mhm.
wrote, but that's a really good,
That's a
easy
good
way to imagine it. Just it expands as it travels.
That's a good example.
Mhm.
A really good analogy. Mhm.
All
agree.
right, perfect. And Sarah, you're going to take number 6. It says, positive beam limitation is a safety feature that ensures the size of the X-ray field is no larger than them.
So yeah, so I was talking about the both on here it says detector dimensions. So that's again the size of the IR. So that's what I was talking about in the beginning. That's one of the principal rules, right? That we never should open the collimation over the size of the detector because that information is just gonna be lost anyway, and that's just contributing to scatter and patient dose. So and I didn't put anatomy of interest because the safety feature, that's what the PBL does, is basically set it to the size of the dimensions of the IR. So that's why I went ahead and picked that. But and I'll find myself too sometimes on portables, it's hard to, it doesn't have that feature. So you really have to be careful and make sure you're collimating down.
Mhm.
Exactly. Yeah, I agree. And also, even if you're in the room, we have to be mindful of the SID. For example, the other day, I was about to do a pelvis at 72 just because I'm so used to having that distance to make sure I included everything. And then I call it in, but the text did tell me that it has to be at 40 inches. And the point is that, yeah, even if you are, even if the tube has the limitation of the collimator, if you increase the distance, it's just gonna extend beyond that. So
Yeah, that's a good
Right.
point.
That's interesting. That's
Mhm.
interesting that your texts tell you that because we're at my site, they tell me to bring it, like, especially because we have larger patients who require a portable for their abdomens.
Mhm.
They say lift it and get the patient as low and the tube is high, and then just collimate to the IR.
Okay.
That's a good point for larger patients because I think Merrill states 40 to 48 inches is recommended. But yeah, if you have someone small and you're backed up to 72, then you probably have a lot of open on the side because the normal pelvis, and even if the patient looks large, their anatomy is still the same as someone that's small, right? Their pelvis is
Exactly.
still the same size. So also something to be mindful of.
Yeah, I think that's one of the hard parts with the bigger patients. Also, when they are supine, I mean, gravity is pushing down their bodies, so they expand a little bit, but the bones are still in the same place. But yeah, for abdomen, we do the same thing. Increase SID as much as we can, but for pelvis, they wanted me to use specifically 40 inches.
Oh, the pelvis. I'm sorry, I thought you said the KV.
Yeah, no, you're fine. All right. And now we're going on to number 7. That one is for me. It says, what term describes the component of the X-ray assembly that is manipulated by the operator to precisely define the size of the X-ray field? And I put, there are 2 types of collimators in the tube. One is fixed and can't be changed. It restricts the beam to go out in one direction, and it has the max field size. That's what we were talking about, and I believe it's 17 by 17. And the other is adjustable, and the operator can decrease the field to the specific dimension of the anatomy. So the answer was adjustable collimation.
Mhm.
Mhm.
I agree.
Yeah, I got that too.
And then tells
Yeah,
us that
same.
too.
I agree. Yeah, since we're talking about which one can be manipulated, that's I think the only option that we as technologists can control.
Exactly. Perfect. And anybody have any other answer for that one or explanation? All right, then we're going to go on to number 8. Which of the following describes the primary benefit of collimating the exposure field size to only the required anatomy? And this one is for Sasha.
For that one, I got a decrease in the patient's effective dose, and again, it has to do with the anatomy of interest and not exposing the tissue or any organs. And I didn't put the skin dose because I believe that the exposure size doesn't directly affect the skin dose.
Mhm. Perfect.
Yeah, I agree.
Yeah, me
Yeah, I
too.
almost put the skin dose on that one and then realized it is effective dose instead.
Mhm. Yeah, and it's good that you mentioned the difference between the two, because that also goes along with our lectures. So it's a good reminder of the difference between those two. All right, anybody else? No? Okay. Then we're going to do number 9. This one is for Kendra. And correct collimation can increase image quality due to a decrease in.
In the scatter radiation, and then in this whole video, it was saying, the main thing was patient dose that we're decreasing, and then scatter radiation was the secondary because the beam can bounce off, the anatomy, surrounding anatomy and create scatter in
Mhm.
what you're trying to look at.
Exactly. Yes, I agree with that. The more field you have, the more scatter can be created because the bigger chance that the X-rays won't be absorbed or won't make it to the IR, basically. Does anybody have something else? No.
No, I agree. And also we want less scatter so that we can increase the image contrast. And that's definitely a big role in it. So
Definitely. Yeah, good mention of the contrast because they are inversely proportional, contrast and scatter. Perfect. All right. And Viviana, you're going to take the last one. This one had a set of images, A through D, and it asks which of the following images represents the ideal collimation for imaging the lumbar spine?
So for this one, I chose B because it has the ideal collimation, and the other ones, one it's too small, it's coned down, and then the other ones, I think D, it was open,
Mhm.
like wide a lot, and so B has the, what I would say, like the perfect collimation for the exposure we need for that anatomy of interest.
Definitely agreed because you don't want to collimate so tight that you risk cutting off anatomy. And
I think they
also,
cut off the transverse process in the first one too.
yeah,
Yeah.
that's what it
Yeah.
looks like.
Mhm. And then D is crazy because you're getting even outside the patient's
Yeah, that's an abdomen right there.
body.
Yeah, I was gonna say that.
And then C is still way too much. You're getting all of the organs basically.
Mhm.
yeah. And for A too, I think I didn't even notice the transverse process at all, but what I was looking at, I was like, well, I think we should have the SI joints in there. It just was looking a little too small. So, and unfortunately, that would be a repeat exam then. And so
Mhm.
we're basically doubling the patient dose
Exactly.
with collimating too much. So, collimation is, you have to be careful.
That's
Definitely.
exactly what I was thinking for the first one. That is just if you clip, you're gonna have to expose the patient again.
Yeah.
Mhm.
They
Yeah.
say don't call yourself out of a job at my side. Have you guys heard that?
Exactly, yeah. Especially since we are still students, I think it's safer just to open up the collimation a little more and also the technique do a little higher than we think it might be because like we saw also in 111 class, if we get too much exposure, we can still fix it. But if we have an image that is underexposed, there's no way of getting rid of the model or the noise. All right, and I think that's it. Those are all of the questions. Does anybody have any other comment to add?
No,
No.
that, but it was just a good refresher too on collimation and just to kind of test our knowledge, make sure we all are on the same page here, right?
Yeah, exactly. It's good to remember all of this from last semester, make sure that we're still applying it and understand why.
I agree.
All right, perfect. Then I'm going to go ahead and end the session. Thank you very much.
Thank you.